Hello ladies and gentlemen. In this video I'm going to walk you through the intervention handout that was going over metallic and ionic bonding. All right, in this first part we were looking at 3 different pictures and you had to figure out if it was a metallic, ionic, or covalent bond. So looking at this first picture, we see all of these sodium cations and these little circles are representing the electrons. So this would be an example of metallic bonding. In the second example, we have a metal and a nonmetal, and I'm showing you the atom A, the metal, is giving its electron away to atom 2. So the metal is losing its electron, and the nonmetal is gaining its electron. So that would represent a metal plus a nonmetal, which is an ionic bond. Okay, when the metal loses its electron, it becomes positively charged, and we call that the cation. And when the nonmetal gains the electron and becomes negatively charged, we call that the anion. In this third picture here, we have sharing of electrons going on. So in a covalent bond, we have 2 nonmetals, or it could be a nonmetal and a metalloid, and they are achieving that full octet by sharing their electrons. Okay, so remember, every element or atom, in order to reach that stability, they need to have a completely full outer valence shell. All right, for question number 2, you were supposed to use this model of beryllium and fluorine in order to explain how it forms an ionic bond. So beryllium is in group 2 on the periodic table. So given it's in group 2, it's going to have 2 valence electrons. So I'm representing that here with those 2 valence electrons. Fluorine is in group 7 right here, and it has 7 valence electrons. So how this is going to form an ionic bond is beryllium is going to give one of its electrons to this fluorine atom, and now this fluorine atom becomes -1 because it has one more electron than proton. Same thing with this other fluorine atom. The other valence electron is going to be given to this fluorine atom, and now this fluorine atom is going to become -1 charged. So our cation, which is losing the electrons, is beryllium, and our anion, which is gaining the electrons, is fluorine. So I can see in my model that I have 1 beryllium atom, and I have 2 fluorine atoms. That's how I get the chemical formula. Another way I can do it is by looking up the charge of my different elements, and then I can crisscross those charges and then reduce if I need to. And that's all on your flow chart. All right, for question number 3, that's where we were looking at the actual structure of what makes up in a salt. Okay, so this salt is formed between sodium and chlorine. So when sodium loses an electron and chlorine gains an electron, we get this attraction between the positive and the negative ions. Now this is a very strong attraction. So because of this strong attraction, it's going to require more energy to break apart those atoms. So because it has such a high attraction to each other, that means it's going to have a very high boiling point and a very high melting point. And the force of attraction between these 2 ions is called an electrostatic attraction. So when you see electro as the prefix, just think about electrons. And that's what we have in an ionic compound. We have a positive and we have a negative ion attracted to each other. So overall, the ionic compound is going to have a neutral charge. And we saw that when we were up here with beryllium and fluorine. We know that each fluorine atom, or ion in this case, is -1. So if I have two F's at -1, and I have one Be at a +2, these charges are going to all cancel out, and that's going to give me an overall 0 charge. And then for question 6, 7, 8, that was just looking at what is an ion, specifically a polyatomic ion. So when we think of the prefix poly, we're thinking made up of more than one atom. So that's going to be a polyatomic ion. We find these on the back of our periodic table, and they are usually found in parentheses, and they typically end in the ending "ate" or "ite." There's only one of them that's positive, and that's NH4 +1, and we call that ammonium. All right, on the back side of this paper, you had to do a lot of naming and writing practice for Ionic. So I'm just going to go over a couple of these right now. So if we look at the very first one, this is your basic your basic ionic compound. So this would be like a level 1. So if I look at lithium, I know that lithium is in group 1, and that's why it is +1 charged. So here's my lithium, +1. I'm then going to find chlorine on the front of my periodic table, and it's right here, and it has a -1 charge. Now, is my metal a transition metal? Given it's in the first group, it's not, so that means I don't need a Roman numeral. So all I do is I write my symbol with the charge, and then I crisscross those charges, and I get LiCl. If you have the same number and just a different sign, they're just going to cancel out their charges. So you can just write the element symbols together. Okay? All right. So now let's look at one where we're working backwards. So here I have Al2O3. So I'm going to write the name of my Al, which is aluminum. I'm then going to write O, which is oxygen. Now I'm going to ask myself, is aluminum a transition metal? Given aluminum is right here, and I know it's positively 3 charged, and it's not in this box, I'm then going to say that no, it is not a transition metal. So once I know that, all I have to do is write the name of my metal, and then I change the ending of my nonmetal to IDE. Okay, let's look at one that has a Roman numeral. So now I have copper 2 bromide. Okay, remember that we use Roman numerals when we have a transition metal. So that's what's going to tell us the charge of that transition metal. So I'm going to write the symbol for copper, which is Cu, and then that 2 tells me that it's +2 charge. I'm going to write the symbol for bromine, which is Br, and then I'm going to find its charge on the periodic table. It's located here in group 7, so I see it's -1. Once I know my charges and my symbols, I'm going to crisscross, and then I'm going to write my formula. So that's going to be CuBr2. Okay, let's look at this one going backwards. This one can be a little tricky. So here I have TiCl4. So Ti, if I find it on my periodic table, Ti is right here. Now that's a transition metal, so I know I'm going to need a Roman numeral. Cl is chlorine. So how do I know what Roman numeral I need to use? So there's 2 ways you can do it. The first way is, as we see, we have 4 chlorines. So I can write my chlorine symbol out, and I know each chlorine is a -1 charge. So that gives me a total of a -4 charge for my non-metal. Now I know that I have to have the same charge for my metal because these have to cancel out. So because I only have 1 titanium, that titanium must be +4 charged. Now the shortcut trick is you can look at the subscripts that you have underneath the chlorine, And you can just reverse that crisscross and see that the 4 came from titanium. And there's no number here, so this would tell me that that was -1. So then I would use that 4, and that would become my Roman numeral for my name. So that's going to be titanium 4 chloride. Okay, we'll do one more, and then you guys will be good to go and try and do this on your own. Okay, so for this one, we see that we have an ending that ends in 8. So if you see 8, you know that's a polyatomic ion found on the back of your periodic table. Now, sodium is not a transition metal, so I don't need a Roman numeral. So I'm going to look up the symbol for sodium. It's +1. I'm going to find carbonate on the back of my periodic table, which is right here, CO3 -2. I'm going to put it in parentheses. That way I'm not going to move that 3. So it's going to be CO3 -2. Once I know my symbols and I have my charges, I'm going to crisscross those charges, and I'm going to get Na2CO3. Okay? All right, ladies and gentlemen, go ahead and try and do the rest of these on your own. I am going to show you the key, so I'm going to show you the key for the first ones up here. I do want you to try and do some of these on your own. So at least you can use this to check your answers.